Okay, so I'm going to be talking about sidechains as a sort of general extension mechanism for Bitcoin and UTXO-related chains. So basically the idea with sidechains is to build on top of a secure base, and we look to Bitcoin to do that because it's the chain with the most, with a lot of metrics are ahead on Bitcoin. Basically, the amount of proof of work security, modularity, development resources, and the length of time the chain has been running, the most practical fungibility and finality. And when you're building second layer systems, you want to be able to depend upon the base layer. So I think Bitcoin's approach is to be conservative and build things in a modular way. So upgrades tend to be backwards compatible, and there's been a lot of work over time on adding more modularity to the Bitcoin sort of internal architecture, software architecture. For example, libconsensus, so the consensus critical code, has been increasingly pulled out into a library. And sidechains are a kind of higher level of modularity. So there's also the most active chain for software development with many different software developers and across libraries, exchange integrations, services. It makes the software development a little complicated because you have to get consensus, which in this case is a different kind of consensus, not blockchain consensus, but an IETF sort of standardization-like consensus process, and reach a very high security bar. So as an example of another layer 2, people will be very familiar with Lightning, which is just a way to make higher scalability, faster payments with a different security trade-off. And sidechains are another layer 2 with different trade-offs to Lightning. Lightning is only able to reflect the features of the underlying chain, where sidechains can add opt-in innovations. So they can make some quite radical departures in terms of features and risk trade-offs. They're able to do that because the sidechain itself acts as a security isolation mechanism. So the major security risk for a blockchain is an accidental split in consensus. And so it has some very strong demands on bitwise compatibility, resistance to forks, where, for example, an implementation may be slightly bitwise different on an ARM processor versus Intel, or on a 32 processor versus 64. So some quite low-level considerations come into play. With a sidechain, that risk is isolated in the sidechain, which is to say if there's a mistake in a sidechain that introduces a split, that affects only the sidechain and not Bitcoin. There are multiple methods for doing sidechains. So federated is one that's in use now. Merge mine is another one where Bitcoin miners also participate in the processing of sidechain blocks. And there are a couple of other hybrid approaches. So I'm going to talk in more detail about one that I'm very familiar with, which is the Liquid sidechain by Blockstream. It's built on an open source platform called Elements, and there are some other projects using Elements as well. So Liquid itself is optimized for exchange traders, and the blocks are not mined, but signed by hardware modules operated by the exchange participants. It offers advantages to exchange traders because it improves their custody risk. They don't have to rely on custody of single exchanges. Example of the new features we've added showing the sort of extensibility and major new things you can do in the sidechain model one is confidential transactions, which is a way to get better commercial confidentiality for trading transactions. You can use it as a user as well. There are smartphone wallets. You can install it, get some Bitcoin or US dollars in different formats on the Liquid network and transact peer-to-peer and create assets yourself as a sort of software developer. And it has some smart contract extensions and a built-in atomic swap mechanism, which is useful for OTC traders. So Liquid is operated by exchanges. There are about 35 exchanges today. There are multiple wallets, smartphone wallet platform, which is also multi-platform, Liquid QT, which is similar to Bitcoin QT, and RenRenBit, which is a third-party wallet. There's the swap tool I mentioned. There's hardware wallet support so that people can store the assets on Liquid on a familiar Ledger and Trezor-like hardware wallet platforms. There's a block explorer, and the other major feature is that you can issue assets on it, so there's a way to issue securities. These are the Liquid members, just a number of exchanges, trading desks, wallets, and some infrastructure companies. So I'll explain a bit more about what confidential transactions means and how it works. So basically, even though there's a block explorer and you can look at the transactions, look at the input and output addresses, so it has a degree of traceability, as Bitcoin has, and a degree of transparency. The transparency is intentionally limited to preserve the confidentiality of the trading information of traders on the network. And that's done using homomorphic encryption. So the amounts of the transaction, how many Bitcoins have been traded, how many US dollars have been traded, and if it's an atomic swap, that information would tell you the execution price. So it could also hide the trade price. And even though it's encrypted, it's able to be publicly auditable. There's a form of encryption which you can still test that the amounts add up. There are some clever but conservative cryptography you need to do this. One of them is a range proof, and we today use a Borromean ring signature. We have a bulletproof version as well, which we may roll out in a future version. And there is also a post-quantum protected variant which could be used. There are other variants of sidechains. So one of the aspects of the sidechain is the security model is not quite the same. And so there is a prospect to get in the future to a unilateral sidechain, which just means a more Lightning-like reactive security model, where you preemptively request to remove funds, and it's up to the participants operating the sidechain to counteract that if it's incorrect. So I mentioned about smart contracting extensions in sidechains. So at Blockstream, we've been working on low-level smart contracting language for Bitcoin and Bitcoin-like chains called Simplicity. And this will find its way into the Elements open source platform and into the Liquid sidechain so that people can try it out. It is introspecting, which is one of the limits of Bitcoin scripts today, that they're not introspecting. It's very low level, but it's formal. It has formal semantics designed for formal proving systems. So it can prove things about the correctness and security of the script in all conditions. So this is designed to reduce the effect where other blockchain smart contract systems have had issues where they've lost funds because the behavior of the smart contract has not been understood under all circumstances, and people have found surprising ways to bypass the expected behavior. So I don't have time to go through all the details. There are other presentations online, but basically it's a low-level language, so think about sort of assembly language, but more mathematical and logic, semantic oriented. There is an interpreter for it. Higher level functions are implemented using it. It's sufficiently low level that it doesn't have, for example, a 32-bit adder. You're really operating at kind of bit operations level, but everything else is defined upwards in this mathematical language. So then ultimately you're able to mathematically reason about everything written in it. The language is assembled, so I wouldn't really say it's compiled because it's sufficiently low level that it's just assembled into a binary. The binary is executed by the bit machine, the bit machine being the virtual machine that executes it. It has 9 primitive operators, sort of low-level mathematical operations. There is an implementation itself with a formal proof, so this is a quite interesting and strong statement that the Coq implementation of Simplicity has been formally verified to correctly execute all Simplicity programs. Additionally, there's a C implementation, and we're working on a formal proof that the C implementation is also correct. And the way we do that is to use the verifiable C project from Princeton to prove equivalence of the C implementation to the other simplicity interpreter implementation, and from there have a proof of correctness. And because it's all formal proof based, we can do interesting things to talk about the behavior of the contract. So for example, we can prove that it doesn't overflow any array bounds. We can prove the maximum runtime. We can prove things about the maximum memory consumption. Just to show the kind of low-level mathematical syntax, this is the syntax, and this is the full semantics. So you can see they're very low-level sort of set bit string operations. So what does it mean if Bitcoin or UTXO-based blockchain had simplicity today? So you can think of simplicity as a self-extensibility for Bitcoin-related blockchains. And so there are some extensions being considered for Bitcoin today, and there have been a number in the past which have been ultimately implemented via soft fork, so a backwards compatible upgrade to Bitcoin. Now, if simplicity were itself soft forked into Bitcoin, let's say, and two of the changes being considered for Bitcoin into next year are Schnorr signatures, which is a more efficient signature format, and Taproot, which is a kind of more compact if branch. Those wouldn't need to be implemented as a soft fork. They could be implemented directly with simplicity and interpreted. Similarly, there's an extension being considered for Lightning that, again, could be implemented directly. And one thing to notice is that that means and these implementations can also be implemented in native C and then shown to be equivalent, and people can then upgrade the software to have a native implementation of something that becomes popular to use. So one thing to notice there is that if you're running an old node, sort of an older version of the software, you're still fully validating what's happening. You're just running interpreted code for, let's say, a Schnorr signature implementation, whereas if you have the native version, the only difference is you're faster. Today with soft forks, if you don't upgrade after the activation, you're partly assuming the correctness of the valuation of miners. So it changes the dynamic there to improve security. So with this kind of self-extensibility, you can do many things that have been considered in a Bitcoin-related system, like vaults, which are kind of virtual time lock vaults that is enforced by the blockchain itself. So you give notice that you want to withdraw, let's say, funds from an exchange cold wallet, and during the notice period, that can be canceled. Velocity limits could be implemented with on-chain enforcement as an alternative to hot and cold wallet, sort of semi-automated management. And we can do more interesting things with the swap tool I mentioned. So for example, we could do a blockchain enforced limit order using this mechanism. So where is simplicity today? So we did a developer preview release in August, and we're currently working on Jets, which is to make more efficient implementations of common library operations available in simplicity so that it is not as much interpreting the low-level aspects to improve performance. So we're targeting to make that available in Elements and Liquid next year. And simplicity is designed to be Bitcoin compatible and actually dates back originally in concept to 2012, long before Blockstream in a Bitcoin context. So it is designed to be Bitcoin compatible. So maybe in the years ahead, after people have had some experience using it on the Elements open source platform and using it live in Liquid, there might be interest to see something like that become available in Bitcoin itself. There's further information there about simplicity. So that's the end of my talk. I don't know if we have time for questions. Okay.